Forgot to do the intro animation. All right, here we go. Hello, everyone. Welcome to another Planetarium live stream. We're switching things up. Phoebe is featuring at the beginning of the show. Welcome, welcome. I am your Planetarium Manager, Patrick Hess, and we are going to take a little tour of our spring night sky today. We're going to see what's up this season, and we're also going to look at what's been going on in the world of astronomy and space exploration news over the past month. Thank you to everybody who's tuning in for the first time. If you are a first-time watcher, we do these streams every month, and you can find recordings of all of our past live streams on our YouTube channel, youtube.com/KCPlanetarium. And you'll also find curated playlists of all the shows we've done, covering all sorts of things like tours of the solar system, celestial navigation. You'll also see my assistant Phoebe featured in many of the shows as well. And for our longtime watchers, this is our 94th live stream. Pretty incredible. We've been doing these for over 3 years now. And woo, Phoebe, that's a good stretch. Yeah, we're really thankful for everybody's support. This is a live stream, so if you are watching today on June 5th at 6 p.m. Central, let us know. Jump into the comments section. We love to hear where you're watching from. If you have any questions during tonight's stream, of course, check that out. Or throw those in the comment section as well. Phoebe, are you ready to hit the sack and head back to your cage? We're doing a lot of stretches right now. Phoebe's doing pretty well. What do you think? Tweet. All right. We're waiting for comments to come in, but we'll go ahead and get things started. I'm going to pass Phoebe off, though, here. So if you wouldn't mind... oh, wait a minute. What's this right here? Well, I'm going to introduce you to my second assistant. Just a little personal news update. This is Emily, my fiance. We got engaged this weekend, and she's been behind the scenes, being the Phoebe wrangler. You've probably seen her hand a few times. Of course, Phoebe's not going to step up today. So anyway, just wanted to share that life update with all of our lovely watchers and supporters. And you'll be seeing more of Emily in the future. I've got some big plans as we're heading towards our 100th episode. We'll be doing some more live streams, probably from our living room, maybe even making a comet. That was a really fun stream we did a number of years ago. So we'll need an extra pair of hands for that, and wings, of course, Phoebe. So anyway, just wanted to introduce Emily to everybody and share the good news that I got engaged. So thank you, Emily.
Hello and goodbye.
Bye, Phoebe. All right, everyone. So let's jump in. And we're already getting some comments in the comment section from people watching. We've got Susie saying, hello, first-time viewer, love the background and the galah. That's very good. Phoebe is a galah, which is a rose-breasted cockatoo, as we call them in the States. Fun fact, Phoebe is native to Australia, and in the Aboriginal language of Australia, galah means fool, which they've named the parrots because they're very silly over there. We've got Wendy tuning in from the Country Club Plaza. Thanks for watching tonight, Wendy. April's watching from North Kansas City as well. Kim from Kansas City. And Beth says, congratulations, Wendy, as well. Thank you to all the congratulations, everyone. I just wanted to share that good news since I've been doing these for a number of years. But that is the biggest life update I've had over the past 3+ years. And David's watching from the universe. Me too, David. Sherry is tuning in as well, saying congrats. And we've got Jerry saying, what great news. Good to see you, Jerry. Thanks for tuning in tonight. There's also a cat stuck in this room that maybe Emily will let out. I'm sorry, Dewey. Dewey, do you want to come here and feature in this live stream as well? All right, things are going off the rails. April says hello to Emily and congratulations. And Kim says, hope everyone is having a good evening. Right back at you, Kim. And I hope everybody's ready for tonight's live stream. Let's jump into a couple quick announcements goings on around the planetarium. And the good news that I want to share is that the planetarium is back online. We've been closed, we've been open, but our regular shows have been offline for a couple of months. We've been doing laser shows in the meantime as we've been repairing some of our projection systems, but those repairs are done. We have the new equipment all installed, and we are back open with our public regular schedule, which includes our live star tour, Sky Station Live, as well as Destination Solar System, which is our blast-off journey through the solar system. So please come visit us at the planetarium. We're open 7 days a week in the summertime. And we are excited to get back to our regular schedule. Our schedule is as follows here, by the way. We've got shows, like I said, every day during the week, 2 star tours every day as well. So check out that schedule. Come visit us. Tickets are $8 and $5 for Union Station members. Got a couple other people in the comment section. We've got Andrew saying hi from Concordia. Thanks for watching tonight, Andrew. Michelle's watching from Clearwater. We've got Melania watching or saying, bring the cat. I would love to, but Dewey's very excited to get out of this room, unfortunately. Dewey, come here. Come here. Yeah, Dewey's very concerned. I'm very sorry, Dewey. I'll let you out in just a second. We've got Russell, who's very entertained by this whole situation. Susie's watching from Blazing Out Las Vegas. And Jerry says they enjoyed the Sky Station show. Excellent, Jerry. I'm sorry I missed you when you came to visit, but I'm glad you enjoyed the showing. Tammy says hello from Iowa. Thanks for watching tonight, Tammy. Great to see you again as well. So let's just jump into our segment of the show where we talk about what's up. Let's see what's up. First of all, in our night sky, as we get to the end of springtime, we are coming up on summer. I know it already feels like summer, but we aren't quite at the official start of summer, which is the summer solstice, the longest day of the year. But in the meantime, we can definitely see what's up in our night sky. And we're already looking at our night sky here tonight. This is at 10:30 tonight, a little bit past sunset. We have already traveled away from the city lights, away from the light pollution of town as well. And we're actually going to start over in the west, because the first thing you'll probably notice tonight, even before the sun finishes setting, is a very bright point of light shining in the west. It's so bright you'll see it before the sun sets, like I said, and you may notice that it looks a bit different than other objects nearby. You may be able to tell, hopefully, in the stream, that the stars in our virtual planetarium are twinkling, just like the real stars twinkle. Stars twinkle because they're very far away from Earth, and by the time a distant star's light reaches our planet, just a tiny amount of it is able to actually penetrate the Earth's atmosphere, and all the gases in our atmosphere causes that little speck of light to become distorted, a little wobbly and twinkly. And that's why stars twinkle. But that bright point of light I pointed out earlier is not twinkling. This point of light is much closer than distant stars, so more of its light is reflected back towards Earth, and it appears as a full disk of light, so it's not disrupted by our atmosphere. This is a planet, and specifically it's the planet Venus. That's right, Venus is the evening star right now. It's not a star, but it's often nicknamed the evening star because it does shine so brightly. Sometimes it's nicknamed the morning star as well. And the reason that it's nicknamed the evening star and morning star is because the Venus is closer to the sun than the Earth is, so will always appear close to the sun in our sky. So you'll never see Venus at midnight. You'll always see it either right before sunset, or right around sunset, or right around sunrise. And right now, it is around sunset. Now, Venus just reached its greatest western elongation, which means that it was at its highest point in the sky, the best time to view it just a couple days ago. But it is starting to get a little bit less visible. Now we're going to zoom in on Venus here, and we can see another cool feature about Venus is that Venus has phases. So Venus is about half full right now, just like the moon has phases. We could call it its third quarter phase, where it's a quarter of the way through its cycle. It will be getting bigger, but also less full, reaching sort of a crescent phase pretty soon, and it'll be sort of disappearing out of sight in the near future. So that is Venus. Now, Venus is not the only planet that's visible tonight. We can also see Mars. Now, Mars is very far away from Earth right now. In fact, it's been getting farther away from us over the past few weeks. And I wanted to show you a chart demonstrating that. Here we go. Wolfram Alpha is a great sort of mathy Google where you can Google crazy things like the distance to Mars. And you can see a chart here. Mars was at its closest approach at the end of last year, but it is getting farther away. and it will be very far away this fall. So Mars is very hard to spot actually right now. You'll see it as a red point of light, and it's actually so far away it might even twinkle a little bit, even though it is a planet. If you're curious, there are charts available to show us planet visibility, so this will kind of give us details about the visibility of planets. Now, Uranus and Neptune are not visible with the naked eye, but with decently powerful telescopes you can catch them. But as you can see, Jupiter and Saturn are another pair of visible planets, but they're visible in the morning right now, whereas Venus and Mars are up in the evening. Now, Mercury can sometimes be seen depending on the sky conditions, but it'll be visible right at dawn if you're looking for that as well. It's always visible at dusk or dawn because it is even closer to the sun than Venus is. So Venus is definitely a very prominent feature in our night sky right now. Let's actually jet over here to the east because I want to point out 3 bright stars that are starting to rise in the east right now. They form a nice big triangle, and as we approach summertime, they'll be seen prominently in our summer skies. And this triangle is nicknamed the Summer Triangle. And it is a tool that some people have used through history to track the changing seasons. As we reach the end of spring, you'll see these 3 stars rising in the early evening. And as soon as you can see all 3 up after sunset, that tells you summer is here. Now, these 3 stars are part of 3 separate constellations. The 3rd star is not all the way up, or its constellation isn't all the way up, but it is part of a constellation called, there we go, called Aquila, the Eagle. And this star's name is Altair. And then we also have this star here, which is named Deneb. Deneb means tail in Arabic, and it's part of a cross-shaped constellation called Cygnus, the Swan. It's pretty simple. There's the swan's neck and its outstretched wings. And again, Deneb means tail. And then the 3rd star is called Vega. It's a very bright star, actually. It's the 5th brightest star in the night sky. And it's part of a tiny little diamond constellation called Lyra the Harp. So these 3 stars are shining very prominently. You'll also find them near the Milky Way galaxy, which is a little bit hard to see in the springtime. But if we fast forward a little bit and let the stars rise higher, you can see what the stars will look like in the summertime in the earlier evening. You'll also be able to see the Milky Way kind of passing through the Summer Triangle. So the Summer Triangle you can also use to find the Milky Way. The core of the Milky Way galaxy, its densest and brightest portion, is right over here near this bright red star, which is part of the constellation Scorpius. So a few interesting things starting to rise in our late spring skies. Oh, that kind of rhymed, didn't it? Now, setting in the west, though, is a constellation I want to point out. This is a sort of a winter and spring constellation, and it'll be out of sight pretty soon. It's Leo the Lion. You can spot Leo by using a star pattern that kind of looks like a backwards question mark or a coat hanger hook. This is Leo's head and his mane. Leo's body is over here. Here are his front paws, and there's his tail. Leo represents the Nemean lion. This was the ferocious beast that Hercules fought and defeated during the first of his 12 labors. Now, there's a deep space object inside of Leo that I want to point out. Now, unfortunately, it's not really visible in our Stellarium software, but I'll still be able to show it to you. It's right around here, near this little cluster of stars that we can see in Stellarium, but we'll have to zoom even further to see an object called the Cosmic Horseshoe. And I'm going to pull up a photo here if my thing will cooperate. There we go. All right, so the Cosmic Horseshoe is right here. So this is an object inside of Leo. Now, to give you an idea of how zoomed in we are, in this single photograph, there are only 2 stars. These 2 points of light right here with these diffraction spikes, these crosses. Every other object you're seeing here is actually a galaxy. Each galaxy contains billions of its own stars. And this warped shape over here that looks like a horseshoe, this is the Cosmic Horseshoe. Now, when this photograph was taken about a decade ago by the Hubble Space Telescope, we accidentally stumbled upon this image. And what we are seeing here is gravitational lensing. Now let me pull up my PowerPoint again. All right, there we go. So There's the picture of the cosmic horseshoe again. And what we're seeing here are actually two galaxies. There's a yellow elliptical galaxy, which is just an older galaxy that doesn't really have a shape to it. It's just sort of a big blob of stars. And then there is a spiral galaxy, similar to the Milky Way. Now, the Milky Way does not look like a horseshoe, spoiler alert. But what we're actually seeing here is gravity bending light. So this diagram shows us what's happening. This yellow galaxy is in front of the blue galaxy. And normally we wouldn't be able to see the blue galaxy because it is obstructed by the yellow one. But what's actually happening is that the light from this blue galaxy, as it travels away from the galaxy, gets pulled by the gravity from the yellow galaxy. So as the light is passing the yellow galaxy, its path gets bent and distorted, warping. And here on Earth, we end up seeing it in this warped and distorted shape. So this photograph is photographic evidence that gravity bends light. Now, we've theorized that gravity was able to bend light for quite a while, and there were experiments that were actually used to prove this. All the way back in 1919, actually, over 100 years ago, we did an experiment where we basically, where scientists basically photographed stars near the sun during a solar eclipse. So we've basically what happened is we charted out the position of stars, and then during a solar eclipse, when the moon was covering the light from the sun, we photographed those same stars right next to the sun. And what we observed is that the light from those stars was being bent by the gravity from our own sun. So even our sun is big enough that its gravity can bend light. And the stars that we observed were actually in a slightly incorrect position, or their apparent position was slightly off versus their actual position. So we've actually known and been able to prove that gravity can bend light, but it's pretty cool that we can just also take a picture of the universe and we can see evidence of that as well. Now, this gravitational lensing seen in the cosmic horseshoe can also help scientists to figure out other things about our universe. For example, what would a black hole look like? Now, we've covered in the past the fact that we have taken photos of black holes before, but those photos are very fuzzy and very far away, and we don't really see a lot of detail. But what would a black hole actually look like if we could see it up close? Well, we can use photographs like the cosmic horseshoe to make inferences about what they might look like. Now, there is a black hole in our galaxy, at the center of our galaxy. In fact, it's called Sagittarius A star, and we can journey there using another piece of software called Space Engine. And if we zoom all the way in to the black hole at the center of our galaxy, we'll see a similar effect. Now, this is not a photograph, obviously, but using images like the cosmic horseshoe, we can figure out what objects like black holes would look like. My screen is getting a little laggy. Hopefully you can still hear me on the stream. We'll just try to show you a very slow animation of the light bending around the black hole. So again, using data and observations from photos like the cosmic horseshoe, we can make inferences about what other objects in space might look like a black hole. All right. Hopefully I didn't cut out too much there. Hopefully we're back online. But I wanted to show that off. And this actually leads into my first news update, which is also about black holes. But first of all, I'm going to check into the comments to see if anybody is leaving any comments. If you're still watching, let us know. We'd love to hear your questions or comments, or if you want to let us know where you're watching from, it's always fun to see that as well. We've got Melania asking if the Big Dipper is visible, and it absolutely is. Let me go back to Stellarium for you. If we zoom back out and go over to the northern sky, the Big Dipper is always visible in the northern sky. It's right up here. You can find it 7 bright stars in the north. And no matter the time of night or the time of the year, the Big Dipper is always up. Not every star or constellation will stay up all year long, but the Big Dipper will. We have a name for that, actually. We call objects that stay up all year circumpolar. And that's because as the night goes on, or as the year goes on, they will circle around the pole, which in this case is the North Star, or Polaris. The North Star is at the end of the Little Dipper, The official scientific or astronomical names for these star patterns are Ursa Major and Ursa Minor, which are the Big Bear and the Little Bear. So the Big Dipper is visible. It's actually always visible. You can see how even though it gets low in the sky, it'll just circle around and stay up no matter the time of year or the time of night. Maureen says, congratulations on my engagement. Thank you so much, Maureen. We've got Geraldine saying good evening. Thanks for watching, Geraldine. Let us know if you have any questions or comments. James is watching and says congratulations as well. Thank you. And he says, Patrick, did you have stars in your eyes last weekend? I sure did. I've had stars in my eyes for the past 2 years since I've known Emily. All right, we got Michelle saying, we are amazed that gravity can bend light. We haven't seen pictures like that before. It's pretty incredible, isn't it? I just love thinking about how just taking a picture of space it reveals these deeper truths about our universe. Just a picture of space can show us gravity bending light. David's asking, what is the meaning behind the name Artemis for the new NASA moon missions? That's a great question, David. So Artemis in mythology was related to the god Apollo. So Apollo was the name of the original moon missions, right? Where we went to the moon at the end of the 60s and early 70s. And Apollo is the god of the sun, I believe. And Artemis, in Greek mythology at least, is sometimes related to the moon. So there are... Mythology is kind of complicated when it comes to history, but there are some versions of sort of Greek and Greco-Roman mythology that relate Artemis with another sort of goddess or personification called Selene, who was sort of the personification of the moon. And, sometimes they were kind of co-associated. But again, yeah, so she was also the twin brother of Artemis was the twin brother of Apollo, rather. So the Greek gods and goddesses were sort of often associated with each other, and sort of they have many, like, multiple personalities. You can almost say multiple personifications. So Artemis was the twin sister, rather. I misspoke earlier, of Apollo. So they are twins. So it's kind of fitting that our mission back to the moon has a name that is associated with Apollo, since that was our original mission to the moon. We've got Maddie in the comments saying, Joe would like to know, when will Halley's Comet come back next? Halley's Comet is a periodic comet that has a relatively short period. A comet's period is how often it passes by the sun, basically. And its period is about 75 to 79 years. The last time it appeared was 1986, so the next time we expect it is around mid-2061. So mark your calendars, it'll be in a little while. I sure hope I'm retired by then. Yeah, good question. The quick answer. Sherry says, Artemis is the Greek version of Diana. Yes, so Diana, I believe, is the Roman name. So the Roman gods and goddesses were sort of equivalent to the Greek ones. They had equivalent personifications and associations as well. Jerry says, are there many circumpolar constellations? There are, Jerry, but it depends on where you are on Earth. So if I go back over here to Stellarium, and I rewind things, bring the stars back out, the North Star, which is named Polaris, is directly above the North Pole. And so as the Earth rotates, the stars will appear to rotate around Polaris, since we are stationary on Earth, but the Earth is spinning around. Now, here in Kansas City, Polaris is about 40 degrees up into the sky, and that corresponds with our latitude. We're about 40 degrees north latitude here in Kansas City. The farther north you go, the higher up the North Star is. If you go all the way to the North Pole, the North Star is directly above you. If you go all the way to the equator, the North Star is level with the horizon. So the farther north you go, the more of the night sky will be circumpolar. Here in Kansas City, a relatively small region of the night sky is circumpolar, but the farther north you go, the more the night sky will stay up all night. And if you're at the North Pole, every single star will not rise and set because they will just rotate around the North Star. Great question, Jerry. Eric says, did we really go to the moon? And I can confirm we did. I went there recently. Just real quick, I did a whole live stream about whether or not we went to the moon and the evidence proving that we did. But I'll just show you. We have sent probes to orbit the moon recently, as in the past few decades, and they had a high enough resolution pictures, or cameras rather, to actually photograph the moon landing sites. And we were able to see the shadow of the flag on the moon. There we go, as well as the actual footsteps. So here, I'll just show you there. Here is revisiting the Apollo landing site, thanks to the Lunar Reconnaissance Orbiter. And so you can actually see here the descent stage. So this is actually Apollo, this particular one I think is Apollo 17 here. And so you can see the actual footsteps of the astronauts, photos taken from orbiting the moon. So we did indeed go to the moon, but thanks for asking. Melania says, my daughter is asking, what is in a black hole? I told her no one knows. Maybe you could give a more educated response. LOL. That's a great question. And the answer is, that is the answer, though. We don't really know what is inside a black hole. But we do know that black holes are incredibly massive. And we also don't really understand them. We know that essentially they are really, really heavy, but they occupy zero surface area, basically. So they exist at a single point, yet they have this amount of mass. So they have infinite density. Honestly, we just don't understand everything there is to know about black holes. We just know that they are what happens when a massive star explodes, and the forces that actually keep electrons separate, or protons separate from each other, break down, and the atoms are basically squished into a single point, a singularity. Beyond that, we're not sure. Michelle says, my daughters, or 10, 13, would like to know how stars are formed. I would love to go into a great amount of detail explaining that. But the good news is I actually did an entire live stream all about stellar evolution, and it was way back in April of 2020. But if you want to watch an entire show about stellar evolution, we can post a link to that in the comment section so you can watch that and learn all about that. That's a great question. And I hope you watch that stream that explains that. All right, excellent questions. I appreciate everybody jumping in the comments section. Now, speaking of black holes, our first news topic, so we're going to check out what's been going on, what's up in the world of space and astronomy news. And this is a really cool visualization that NASA released earlier this month that shows the comparisons in the size of black holes. So let's check it out here. What we're seeing here is zooming out from the sun and showing the relative size of known black holes. So as we are zooming out here, we can see a black hole right there. Oh, and this black hole, I should mention, the one that you're seeing here, it was a recently discovered black hole. It's the smallest black hole that we found inside a dwarf galaxy. This black hole is about 100,000 times the mass of our sun. So even though it's roughly the same width, or the event horizon, that's that black region, is about the same width as the sun. It's 100,000 times heavier than our sun. And if we continue zooming outwards, we'll see some other notable black holes. Eventually, we'll be able to see the orbits of different planets, and you can see the captions here explaining that as well. There's another black hole we can see in the Circinus galaxy. We'll continue moving out here, and we can see the orbit of the Earth. And we can see a black hole at the center of M32, which is a satellite of the Andromeda galaxy. And we've got Sagittarius A star. This is the black hole that we just visited, the one at the center of our galaxy. It's relatively small, so to speak. It's a little bit smaller than the orbit of Mercury, but it is about 4 million times the mass of our sun. And that's a black hole at the center of our galaxy. Continuing to zoom out, we see some other notable black holes passing the orbits of Saturn, Neptune, and the Kuiper Belt, which is the region outside of the planetary region of our solar system. And we've got another black hole in a neighboring galaxy 150 million times the size of the Sun. Andromeda, our sister galaxy, its black hole is way bigger than our black hole. Its black hole is 140 million times the mass of our Sun. And you can see here the Andromeda black hole is about the width of the orbit of Uranus, it looks like. But we can keep zooming out and we can see that the black hole inside Cygnus A is 2.5 billion times the mass of our Sun, and its entire diameter, that's the diameter of its event horizon, which is the point of no return where light can't even escape, is bigger than the entire size of our solar system. And we can keep zooming out because we have found even bigger black holes. The Oort cloud is the region of our solar system where comets come from. M87 is a neighboring galaxy. That's the galaxy that has the black hole that we took a photo of using the Event Horizon Telescope. And you can see here, there is an even bigger one. The final galaxy in this animation is the galaxy called TON 618. And it is so far away that its light is 10 billion years old. That means that it existed near the beginning of our universe. It's very large. You can see our entire solar system would fit multiple times across its width, the width of its event horizon. So a neat little animation there about black holes I just wanted to share. Hopefully you enjoyed that, y'all. All right, everybody. So got another question. David's in the comment section saying, did the Apollo 11 flag actually get knocked over and buried by the force of the departure? I believe that is the case. Some of the other landing sites, the flag was posted far enough away from the ascent module that they weren't toppled over. But the Apollo 11 flag, I believe fell over, and that's just my my anecdotal memory. But we could look it up. Oh, you know what? NASA has an entire article about the condition of the 6 known flags on the moon. So we do have pictures from the Lunar Reconnaissance Orbiter. And let's see. Okay, here we go. There's the Apollo 11 flag. Neil was studying the altitude indicator, but I looked up long enough to see the flag fall over. So it looks like Buzz Aldrin reported that the flag fell over, and as expected, there's no indication of a flag shadow in the Apollo 11 Lunar Reconnaissance Orbiter images. So looks like that flag did fall over. Apollo 12, apparently there is strong shadows visible in a sequence of images, so it seems like Apollo 11 is still standing. Or Apollo 12's flag is still standing. So a number of them are still standing. Apollo 16's flag, Apollo 17. So there you go. Good question. And Melania says, is it true there are other 800 billion life-supporting planets discovered? Well, there are probably a lot of planets in our universe. Current estimates have at least half of the stars in our galaxy, at least, have a planet around them. Now, in terms of planets that could support life, well, we don't know. We've never found a planet that we for sure know can support life. Thanks to technology from the James Webb Space Telescope and other high-tech telescopes we've sent to space, we have started to detect trace amounts of elements in the atmospheres of exoplanets. An exoplanet is a planet in another solar system, another star system. And some of those planets we've detected evidence that there may be water vapor, at least in the clouds of these planets. Now, we have no proof that there are oceans of water, and for sure no proof of life. The number of exoplanets we've discovered is in the thousands, and again, not all of those planets are life-supporting or even have conditions that may be anywhere close to life-supporting. So, unfortunately, we have not found any places that we know are life-supporting. I will say, in our own backyard, in our very solar system, there are a number of moons that have oceans of liquid water under an icy crust surface. And so we know that there's warm water elsewhere in our solar system. So if there were places that could support life, they actually might be in our own backyard. Alrighty, let's continue on with our news updates. Thank you to everyone who is still watching and everyone who has commented. It's always great to see so many comments and to have some nice interactions. So our first news story is about a private space company called Axiom Space, and they recently carried out the launch of their second private crew mission to the International Space Station. So the private space industry is continuing to grow, and this includes sending astronauts to space. Axiom Space already sent a crew to the International Space Station, and they just sent their second crew just a couple weeks ago. And these 4 astronauts spent a little over a week aboard the International Space Station. They conducted experiments within that orbital lab. This crew included Commander Peggy Whitson, who was a veteran NASA astronaut, pilot John Schaffner, who is a space enthusiast who purchased a ticket for the mission back in 2021, as well as mission specialists Ali Akarni and Ryana Barnawi. Hopefully I pronounced that close to right. And they are members of Saudi Arabia's first class of astronauts. So very exciting. Always great to see a multicultural approach to space. And there is the backup crew, I suppose. But there is the actual crew there aboard the mission. Oh, here's the main crew there. So while they were on the space station for over a week, they conducted a bunch of different science experiments and research projects. One of them was a project to examine the effects of microgravity on the production of stem cells for cancer research. Now, during the stay, the International Space Station actually had 11 astronauts on board, which sounds like quite a bit. You'd think it'd get a bit crowded there. The record is actually 13 people in a single spacecraft, and that was back in 2009. They returned to Earth last Tuesday on May 30th. Now, as I said, this is the second Axiom Space private mission to the International Space Station. Following the return of the first mission, NASA admitted to having learned some important lessons about having private crews on board the space station. Apparently, the first Axiom Space crew members complained that their schedules were too busy for them to be able to enjoy their stay in space. So there you go. Even astronauts can complain about not having enough free time. So apparently, as a result, the space agency updated a few of their plans and rules to give them a little bit more downtime. Now, if you ever wanted to participate in space research, you can do it right here on Earth. In fact, you can do it from the comfort of your own bed. That is, if you're willing to stay in bed for 2 straight months. So there is a brand new study called BRACE, which stands for Bed Rest with Artificial Gravity and Cycling Exercise. And this study is being conducted by the Institute for Space Medicine and Physiology in Toulouse, France. 12 people are about to embark on the world's longest sleepover, all in the name of space research. The group will be confined to beds designed to mimic the rigors of space for 60 days straight. Some volunteers will also be testing strategies that can hopefully reduce the bodily strain caused by lack of gravity, such as exercising while being spun in a centrifuge. So the volunteers will spend every waking and sleeping hour on a bed elevated 6 degrees below the horizon, feet side up, even while showering and using the toilet. As a cardinal rule, at least one shoulder will have to remain on the mattress no matter what. This forces blood and fluid to rush to the head, and coupled with the constant bed rest, will eventually cause a person's muscles to atrophy. The same problem seen with long-term space travel. Now, one group will act as a control, resting the entire time. Another group will regularly cycle on an exercise bike outfitted onto the space bed, following the typical routine that astronauts do to stave off muscle loss. And then a third will cycle while inside a centrifuge machine. The spinning will ideally act as a counterbalance to the loss of gravity in space that's being mimicked by the bed, and should hopefully improve the gains that would come from exercise. So, really interesting, and the researchers associated with this project have said that the results from these types of tests can also be used here on Earth. They can be useful to design better treatments for the elderly, as well as for patients with musculoskeletal conditions and osteoporosis on Earth. So we've talked about in the past, why do we do research about space? Well, there are a lot of ways that research on space can help us here on Earth. All right, let's tune into our monthly segment on the James Webb Space Telescope, and this is Webb Watch. So Webb, which is our next generation space telescope that launched in December of 2021, and has been gazing out into the universe with its infrared imagers to look at some ancient galaxies. It's also being used right here in our backyard, and it's being used to photograph our solar system. And this picture may look pixelated, but it is a very interesting one. So recently, Webb turned its gaze to one of Saturn's moons, Enceladus. So examining other planets, like Saturn and its moons, are useful ways of understanding the dynamics between planets and how they may have formed. It helps us to research exoplanets as well. Enceladus is a tiny icy moon orbiting Saturn. It's a little over 300 miles across, which is less wide than the United Kingdom. In the 2010s, a NASA spacecraft called Cassini discovered geyser-like jets of water vapor coming from the Enceladus. And so we figured out that there was a subsurface ocean, as I mentioned before. So Enceladus, moon of Saturn, has an ocean, and it has liquid geysers. Now, this recent image from Webb photographed a gigantic plume of water, the biggest we've ever seen, over 6,000 miles in length, which is a distance many times greater than the width of Enceladus itself. The team found this geyser was spewing water vapor at a rate of 79 gallons per second, feeding a halo of water vapor around the moon. This image shows that off in a little bit more detail. So essentially, Enceladus is jetting out this water, which is collecting in a big halo around Saturn. Water oceans on other planets and moons are intriguing sites for planetary scientists, since, as we know, water is a crucial element for the persistence of life as we know it. So the more we study water in distant places like Enceladus, the more we understand more about life on Earth. Here's another wacky story about space. You've probably thought that most rockets and satellites are made of metal. Well, Japan wants to send a satellite to space made of wood. That's right, space wood is a thing. Japanese researchers are preparing to launch the world's first satellite made from wood, following a successful experiment on board the International Space Station. In partnership with the Japanese Aerospace Exploration Agency, a team of researchers from Kyoto University exposed 3 different types of wood to the harsh environment outside ISS, and they found that the material was not affected by the surrounding cosmic rays or incoming solar particles after 10 months. The experiment kicked off in March of last year, and they're just releasing the findings now. So they tested a bunch of different wood, and they found that one of the woods worked a little bit better than others. I believe it was magnolia wood. And the results from this experiment will be used to construct a satellite made entirely of wood and some aluminum, which will be used to construct this satellite and launched in 2024. The satellite is nicknamed Lignostella. It won't be entirely made of wood. It'll have some aluminum parts, as I said. So they found that magnolia wood is the most durable kind due to its overall strength. And now, when you think of constructing orbital spacecraft, you'd think hauling lumber out into space wouldn't really make much sense. But this experiment showed that the wood didn't crack or peel or warp or suffer any significant damage after hanging out in low Earth orbit. Wood has a lot of advantages over other materials. For example, it would burn up entirely when re-entering Earth's atmosphere, unlike metal satellites that could break up into pieces of space junk or have a negative environmental impact on our atmosphere. Another advantage is that wood doesn't block electromagnetic waves, so the satellite could house its antennas inside its wooden body rather than on the outside. So this satellite is planned to launch next year, so stay tuned for the first wooden satellite. All right, let's turn our gaze farther out into the outer solar system, and we have a big news update and a reclaiming of the crown, because Saturn now has the most moons in our solar system yet again. Over the past couple of years, we've been following a sort of space race where both Saturn and Jupiter were discovering new moons, or we were discovering new moons of them. And they kept trading places being the most moons. So first it was Jupiter, then Saturn overtook, then Jupiter took the crown back, then Saturn again, then Jupiter. Well, now Saturn takes it back, and I think it'll probably have it for a while, because Saturn went from having 83 known moons, all the way up to a whopping 145. That's right. Scientists recently announced the discovery of 62 additional moons orbiting the ringed planet. So this research group was led by a postdoctoral fellow at Taiwan's Academia Sinica, and their team used a technique known as shift and stack to find any small Saturnian moons that might have eluded astronomers previously. Lo and behold, they definitely struck oil, and the newly discovered moons have been recognized by the International Astronomical Union as being official. So there are officially 145 moons of Saturn now. So basically what they did is they looked at sequential images taken from various telescopes to find moving points, see little dots that were moving slightly between images. They tracked these objects over several years in their data sets to be certain that they were actually moons and not other rogue objects like asteroids, for example. The team was able to identify these moons were as small as 1.5 miles wide. It does beg the question, how small can an object be to still be considered a moon? And there is no official definition. Perhaps if we continue discovering more and more moons of these outer planets, we may have to change those definitions, similar to how Pluto's definition was changed a number of years ago. But for now, Saturn retakes the crown as having most known moons in our solar system, and a whopping 145 known moons. Now, speaking of a planet that only has 2 known moons, let's look at Mars. A new mosaic was released by the Perseverance rover team, and this mosaic of photographs shows evidence of a turbulent river on Mars. Now, the Perseverance rover mission landed on Mars in 2021, and it's been exploring a dried-up river delta that once fed into a large crater lake on the planet. Scientists have found a lot of evidence of water on Mars, but this latest bit of evidence shows that this river that Perseverance is exploring likely had very turbulent and fast currents, that's pretty cool. So there were hundreds of images taken by Perseverance's main camera, and they were assembled into this mosaic image. Basically, this is showing that this river that Perseverance is exploring was moving a lot of water. There are coarse sediment grains and cobbles, large bits of coarse rock, which are indicative of a high-energy river that was carrying a lot of debris at one point. There's plenty of evidence for ancient water on the Martian surface, but Perseverance's mission is unique. The rover has collected a cache of rock samples that will be brought back to Earth in the early 2030s, assuming NASA and scheduling doesn't slip. So Perseverance is dropping these samples to be picked up by later missions. Here's another photograph of this river delta and showing evidence of the strong water currents. All right, now another planet we haven't mentioned in a little while, Jupiter, is set to receive a visitor in the somewhat near future. The Jupiter Icy Moon Explorer, or JUICE for short, is on its 8-year journey to Jupiter, where it will explore Jupiter's moons, Europa, Ganymede, and Callisto, moons that are suspected of harboring subsurface oceans, as I mentioned before, which have potentially habitable conditions. Now, JUICE got off to a good start, launching on April 14th, but flight controllers ran into issues when attempting to deploy the probe's ice-penetrating radar for Icy Moon Exploration, or RIME, antenna. The antenna got stuck within its mounting bracket when they tried to extend it, which was a bit troubling, and engineers were looking into the cause of the issue. They were blaming a tiny stuck pin for causing this anomaly. Now, flight controllers devised several strategies to dislodge the stuck antenna, including a kind of shake-and-bake method in which the probe's thrusters provided the shaking and the sun's rays provided the baking. So they tried to wiggle the antennas out. That did not work, but success finally came a little while ago when controllers fired a non-explosive actuator affixed to the jammed bracket. This delivered a shock that moved the pin by a matter of millimeters and allowed the antenna to unfold. That was back on May 12th, and the firing of a second actuator allowed the final part of the stuck antenna to fully deploy, and the entire apparatus extended to its full intended length. So the antenna is all the way out And the JUICE mission is now on its way to the Jovian system. It is fully suited up with all of its instruments, ready to explore the potentially habitable icy moons of Jupiter. And we will have to wait a little while because the mission just launched, and it will take 8 years for JUICE to get to Jupiter, and it will arrive in 2031. So we will check back in 2031 to see how that mission is going. All right, everyone, we are about to wrap up tonight's stream with our final news topic. So if anybody is still watching and has any questions or comments, be sure to throw those in. But we will jump into our final news story now. And there was a supernova that was discovered. So this is pretty exciting. Supernovas are fairly rare occurrences. They are the result of the death of a massive star, a star that explodes and becomes so bright that we can actually see it from here on Earth. Now, this star, well, actually, it was in a different galaxy entirely, yet it was so bright we can still see it. So this star, dubbed SN 2023 IXF, was discovered by a Japanese astronomer a few days ago, rather, and it was located using from an automated image facility called the Zwicky Transient Facility. This supernova occurred in the Pinwheel Galaxy, a very famous galaxy, Messier Object 101. And this image is showing sort of a before and after, showing the new supernova and how bright it is. Again, this is a star exploding in a different galaxy, a galaxy that is millions of light years away. 21 million light years away, in fact. Yet this is the closest supernova we've seen in the past 5 years, the second closest in the past 10 years, and the second supernova found in the Pinwheel Galaxy in the past 15 years. Supernovas are fairly rare, ones that are visible to us here on Earth at least, but this is an exciting one, and it is actually one you might be able to see for yourself. If you have a 4.5-inch or larger telescope, you can see this supernova. It will likely remain visible for about a month or so. If you end up checking it out, let us know. We might try to set up a telescope and check it out as well. Studying such a close and young supernova may yield new clues about massive stars and how they explode. So it's always exciting when there's a new star in the night sky. All right, everyone. Well, we're going to start wrapping up tonight's stream. I see some people in the comments as already asking some questions. We've got Andrea saying, can you get out of the Milky Way galaxy? Sometimes I wish I could, Andrea. But as it is right now, unless we discover a way to break the laws of physics, it would take quite a while to get out of the Milky Way. The Milky Way is hundreds of thousands or tens of thousands of light years across. And so even if we were traveling at the speed of light, a human within the span of a human lifespan probably wouldn't be able to make it out of the Milky Way galaxy. There's also the problem of we haven't really defined what the edge of the Milky Way is. There are some people who even think that the Milky Way's span stretches out so far that it actually shares some interstellar medium with the Andromeda Galaxy. So what is the edge of the Milky Way anyway? So unfortunately, Andrea, we probably won't get out of the Milky Way anytime soon unless we discover warp travel. But if you do, be sure to let me know. April says, thank you for all this information. Very interesting. You're welcome, April. I hope you enjoyed tonight's stream. Jerry says, thank you. I learned quite a few new things. Glad to hear it, Jerry. Always a pleasure seeing you. We've got Eric saying, great job. Thanks. Thank you for watching, Eric, and for your continued support. And thank you to everyone who watched tonight, including Michelle asking, is a black hole a 2D or 3D object? Michelle, that is a great question. If you consider a black hole a singularity, a single point in space, then you might even say it's a one-dimensional object. But then there are theories about higher dimensional space. Maybe it's a four-dimensional object, and maybe if you travel through a black hole, you travel in time as well. We're not really sure. Some of these questions are so big that we just don't have time to answer them during one live stream. But I appreciate the big thinking, Michelle, and thanks for the question. And thank you, Jenny, for commenting, saying thanks. Very interesting. I appreciate your continued support. Thank you to everyone. I have been your Planetarium Manager, Patrick Hess. Hope you enjoyed tonight's stream. If you want to watch recordings of all of our past live streams, head over to our YouTube channel, youtube.com/KCPlanetarium. And be sure to like and subscribe to us on our Facebook page, facebook.com/kcplanetarium, where you can't miss all of our future news updates about the planetarium and about space. By the way, we ended our daytime run of Laser Taylor Swift, but we are planning on doing some evening showings in the near future. So if you missed Laser Taylor Swift, or if you missed out on getting tickets to her upcoming Kansas City concert, don't worry, we got you covered. Stay tuned on our Facebook page and come by the planetarium and see one of our star tours sometime. Thank you to everyone who watched tonight. Tammy says, thank you, Patrick. We learned a lot as always. Thank you, Tammy, one of our long-time watchers and greatest supporters. I appreciate you, and I appreciate everybody who watched tonight. Have a great evening, everyone. Bye-bye. And Michelle says, thank you. Thank you, Michelle. Bye-bye.